Our final question here with factorization, we've got a very complicated one here. We've got minus m to the power of 4 and n to the power of 2 plus m squared n minus m squared p. Okay, so we have no numerals to take out, so we need to have a look at the pronumerals, and we can find that m, n, m, n, m, p. So m is the only one that's common in all three terms. M is here, there's an m there, and there's an m there. There's an n there, an n there, but there's no one there, so we can only take out the m because it's common in all three. So we've got m outside the brackets. Now we have a look carefully and we can see that m squared is here, and m squared is here, and m to the power of 4 is there. So m squared is common here and here. It's a common factor. So we can put m squared outside of the bracket. That would leave us with the minus is still there. So we've got 4 originally. We've taken 2 outside the bracket. So there must be 2 left over, because 2 and 2 equals the 4. N squared remains there, plus we've taken the 2 out there, so we don't need that term there. We just have the n there, and minus the m squared is outside the bracket, so it's just the p. So we've got m squared minus m squared n squared plus n minus p. And if we expand, we can see that we're right, because m squared times minus m squared n squared equals this. This times this equals this. And this times this equals this. One last thing we want to do here is we want our first term to be a positive number. So we can take the minus one outside of the brackets. Okay, so that would mean we have minus m squared. This would become a positive. So that must become a negative because we want it to be a positive, and a negative times a negative is a positive. This one here would have to be a positive because we want it to be negative there. And a minus times a positive equals a minus. So now our first term is a positive number, so that is it completely factorized.